I'm Anil Kumar, and here is a video to understand very basic concepts of velocity when applied to vectors. The question is, an object moves in a straight line with constant velocity of minus 4i minus 3j. Unit vectors I and j represent a displacement of 1 meter. Time t is measured in seconds. Initially, the object is at minus 4, 6. Find the object's position at t. T is greater than or equal to 0. Find the time when object crosses x-axis. Find the coordinates of x-intercepts. So these are three parts, and we'll try to understand such situations. So let me kind of sketch and then explain. Object moves in a straight line with constant velocity is given to us. So minus 4i minus 3j, and it starts at minus 4 minus 6. So it starts from left side. So I'll sketch this axis so that we are working more towards the negative side. Okay. First, let's look into the direction part for velocity. Minus 4i minus 3j means, let's say this is 4 for us, and let us say this is 3 for us. This is 4 for us. Okay. Minus 4 minus 3. So when I say directions minus 4 minus 3, that means from origin, that is the direction. Do you understand? So that's the direction. But it says initially the object is at minus 4, 6. So initially the object is at minus 4 and 6. If this is 3, so that is 3, 6, right? So the object starts from here. Okay. And then moves parallel to this in this direction. So let me sketch a line which is kind of parallel to this. Does it make sense? So that is how the object is moving. Okay. So, okay, now let's answer our questions. So this is 6, 3. This is 0. Find the object's position at t, where t is greater than or equal to 0. So the position vector for any velocity cases which we'll be working with will be, let's say, xy is position. It starts with the initial position x0, y0 plus time times the velocity vectors vx, vy. That is how we are going to write all our equations. Now here we can see the correlation, direct correlation, right? So the answer will be that xy, the position vector, is equals to initial point means t0, right? Minus 4, 6 plus time parameter t. Velocity is minus 4. So I should write minus 4 and I can write minus 3. So that is the vector equation for position. So object position can be given as this in the form of vector equation, where t is greater than or equal to 0. Does it make sense to you, right? Okay. Find the time when object crosses x-axis. So this is the x-axis, right? And that's the y-axis. So the object crosses x-axis. It really means at this point, y is 0, correct? So we can find t when y is 0 and then the value of x. Okay. So what I'm trying to say, we could write this in parametric form. X is equals to minus 4 minus 4t, and y is equals to 6 minus 3t. Perfect. Now x-intercept means what? X-intercept means y equals to 0. So if I substitute y equals to 0 and calculate t, I'll know the time it takes to get to that place, right? So say 0 equals to 6 minus 3t. So 3t equals to 6. T equals to 6 over 3, which is 2, right? So in 2 seconds, time is in seconds, right? So in 2 seconds, the object will reach here on the x-axis. So find the time an object crosses x-axis. So the answer is t equals to 2 seconds, right? That is important, units. Now part C is the coordinates of x-intercepts. So we know y coordinate is 0. What is x? So In x, we'll substitute t as 2. So we get minus 4 times 2, which is minus 4 minus 8, or minus 12. Okay, so this point is at minus 12. That's what we mean. Okay, so this point is minus 12. So coordinates of x-intercepts are minus 12, 0. Okay, so that is our answer. So we have all our answers here. First answer is this equation, then we have t equals to 2 seconds, and then we have the coordinates as minus 12, 0, right? I hope that helps you to understand the basic concepts of position vector, how it is related with time and velocity. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.